Okay, so we're looking at rates of change, and up to this point, I mean, you guys know that derivatives give a rate of change. But up to this point, we've really just dealt with motion. The cool thing about this is that derivative giving a rate of change is not limited to functions that involve motion. In fact, no matter what the function represents, the derivative is going to give us the rate of change of that value. So, for example, we could have functions that represent a cost of production, or something like that. It could represent area. It could represent population. Like population in a city, or you could even do it as like population of a bacteria. It could be volume. And our derivative in each of these cases will give us the rate of change. Now, when we're talking about cost of production, that rate of change actually has a particular name. It's called what's known as the marginal cost. When and we're going to do an example like this. When a company is trying to determine what it should produce, all right, what they want to do is produce enough to minimize the cost per item. Okay, this is what a lot of small businesses have trouble with initially. They're unable to make enough profit because it costs them so much to produce their product because they're only producing a few of them. If you're able to produce things in bulk, usually you're able to get your costs down. And that might be because, you know, you're able to buy your materials cheaper because you buy those in bulk or whatever, you know. But anyways, you know, marginal cost. The idea is to figure out what that number is of how much I should produce each day or each week or month in order to minimize the cost of each one. And now there is usually a time when, okay, we're producing so much, our cost per item actually starts going back up. Maybe that's because that running our machines that much is causing them to break down more. Or maybe we're having to pay our employees overtime. Or something like that, okay? You can, but all of that can be figured out once you have this derivative, okay? Area, what's a change in area? Or is our area growing as one of the parts that makes up that area changes? We're going to do an example like that as well. A population growth. You know, if we were able to take the population of a city over a few years or whatever and construct some kind of an exponential growth model from that, we could use the derivative to figure out not just the average growth rate like our model would show us, but this would actually tell us the population growth rate at any time in that time period. Okay? And then also volume. This is one that's kind of interesting. You know, think of, you know, you're filling up a bucket with water. Now, if that bucket's a cylinder, it's pretty easy to see. But let's say you're filling up a cone or some other irregularly shaped object. You know, the change in volume actually would be the same throughout that whole process because you just turn the water on and the water's pouring out at the same rate the whole time. But you could look at something related to this, and this is going into a branch of calculus we're not going to get into this year, but if you take calculus in college or if you take AP next year, you will deal with this, is related rates. If our change in volume is, you know, so many gallons per minute, how is that going to affect the change in the depth of our water in this cone? Or even in a cylinder, you know, even in something a little simpler as a cylinder. But you can use derivatives to help you find some of these things, okay? So, I want to look at examples of these first two cases And then I'm gonna have you guys work on some with the remainder of the time just to practice, because that's really all this section needs. It's just applying stuff we've already done to new contexts. So let's take a look here at our cost in dollars of producing X items in a factory each day. Alright, and they came up with this model. One of the operations people in the company most likely did this, working along with the accounting department. They came up with, what are the fixed costs? Alright, our machines are going to be running, the lights have to be turned on, we have to pay insurance or rent or whatever. Those are going to be the fixed costs per day. Then you have the materials for each item. Okay? Each item, let's say it's, $5 for the raw materials for each item that we're going to produce. And then we have labor, all right? And they calculated what that would cost per item. So what we have here is the derivative of this function is going to give us the marginal cost per, and that's the cost per item at that moment, okay? And guys, the cost per item is going to be different based on whether we produce 50 of these or 150, okay? And part of that's because these fixed costs are fixed. They're not going to change. So the cost for each one is going to be a little different. So let's take a few moments here, and I'm going to let you guys try some of this yourself. The second part here, it says find the marginal cost when 150 items are produced and interpret it. Try to put it in your own words. What does that mean in light of the context here? And then they also said here, notice this is just C, not C prime. Find the cost of producing 151 minus the cost of producing 150. And then compare this answer with what you got on B. Okay? So go ahead and do that. I'm not going to talk, but I'll let you work. You can work with somebody if you want.
Like there is with like velocity,
in this context, no.
Okay.
That would just tell you how quickly your cost was changing
Right.
per item. So.
Did you get like 14.375?
Right.
That's just cost per item produced when 150 are produced, right?
Oh, I made a mistake. That's 3
That's
times.
150.
Oh. So that was. You just wrote like right next to both sides.
Oh, you mean for the overall?
Yeah.
Oh, okay. Yeah, I didn't get that. What'd you get?
Right.
What's the increase?
Yeah, it could be in any unit of measure, but we could look at it in dollars.
Well, any type of monetary.
Right.
Okay, for C 151,
Yes. I'll let you have it.
Mm-hmm. Gotta make it not happen. So, put it in. Yeah, leave it.
What'd you get for one?
You still leave it.
8,448.
What?
Okay, wait, I'm doing
Okay, so it costs about 12 to
So 150, is that the one that's using that?
we do 150, right? Yeah. Yeah, so okay. It costs ever so slightly more to produce. So is the marginal cost going to increase
Mm-hmm.
over time?
It can. You know, like we said, I mean, you could be starting to have to pay people overtime, or, you know, your maintenance costs are going up because you're running the machines harder or whatever. So,
I tried to like look at the equation to like the graphing thing, so you can just like trace and plug in the
Mhm.
X value, but it's saying like there's an error. And like when I plug it in, sometimes like I have to like reset it, but like I put it in right.
okay.
I'm like, it should
What kind of an error? Oh
It
wait,
just
it's,
doesn't-
well, hang on one second. Oh, that's the original function, okay. Where?
it's just like it doesn't go. So then
Oh.
I just try to trace it.
I can look at it like 4 or 5 times in my
Yes, I am.
chance I could get one on the
There you
desk.
go.
I'm your trainer.
No, I don't know if that's gonna be perfect, but it gives you a ballpark. And if you look at it, you're probably.
But like, if you try to like trace it to like find like what the X value would be, it just isn't valid.
Well, it's invalid because
And
if you go to your window,
part of
your X max is only
and
at 4
and
days.
Bayonne or something.
So
This is how close.
change your X
And
max.
it's literally
When
like
you use
a
trace,
and
you
you're
can
like,
only
oh,
trace
No, I
values
like
that are
really
within
far.
your window. It doesn't have to be visible, but it has to be within your window. Alright, let's take a look here, okay? We've got the answers up here. C prime of 150 is 14.375. What does that mean?
That's the marginal cost
It's the marginal cost.
of producing 150 items.
Okay. Now, what does that mean? Let's not use the term marginal cost. What?
If you make 150, then it'll cost 14.375 to make each one.
That's right, okay? It'll cost you, if we round to the penny, $14.38 to produce each item. But that's only true when you're making 150 of them. Okay? That's only true when making 150. Notice though, when we look at our difference in cost between making 151 and making 150, it's almost like that 151st one cost $14.44. Now, that's not exactly what it is, okay? That's the difference in overall cost. The actual difference in marginal cost might only be, you know, a few pennies or something, but when you've got 151 of them, you know, the total cost is going to increase $14.44, not $14.38, and that's because the marginal cost at 151 is different than the marginal cost at 150. Okay? Does that make sense? Okay? Alright. So, any questions? Excuse me, questions about this one, or? This is a great concept to keep in mind anytime you're purchasing stuff or you're trying to make things or whatever. This is why people are willing to pay to have a membership at a place like Sam's Club or BJ's or Costco. Because, yeah, you have to pay $50 just to be able to get in the door all year, but you're able to buy things in bulk. And when you buy a greater quantity, they charge you less. Okay? If you go over to Publix and buy a 1 pound package of, you know, ground beef or whatever, they might charge you $3.50, $4 a pound. But if you go over to here to BJ's and you buy a 10-pound package, they might only charge you, you know, $2.90 a pound. Okay? Same meat, but because you're willing to buy more at once, they're charging you less. And guys, that's a really simple example, but that's true throughout business. Any kind of production or purchasing situation, usually the more you buy, you know, the less it'll cost. Even going places like, you know, the zoo or going to Disney, I don't know if Disney does it, but going different, you know, theme parks, if you get a big enough group to go together, you get a group rate. Okay? So, if you're going to go, ask around and see if anyone else is going to go. And if other people are going to go too, you could all go together and buy your tickets together and get a discount. Okay? So, it's a really kind of neat concept, but it's true across all kinds of purchasing applications. Alright, here's another one. This one is going to require that we remember a formula from a while ago. We're finding the rate of change in the area of the triangle as theta changes at the time when theta equals 60 degrees. How do we find area when we're working with two sides and the angle between? Theoretically we could, but that's going to be really complicated because we'll have to use a lot of cosines to find this third side, and since this is a variable...
Can we find the third side?
We could with a lot of cosines, but again, it's going to be a variable quantity dependent on the theta.
Right.
Yeah, third side can't.
So let's not use an area formula that requires the third side.
Can't we cut it in half?
We could, but...
It's like you use the side of the angle.
That, we're in the right ballpark of topics, okay? However, there's an area formula, and if I remember right, I think this is in your formula booklet, so don't worry too much. But, let's see here. Is this in here? They have area of a oh, it is. Area of a triangle. Okay. Now this isn't your just 1/2 base times height. This is actually a variation based on if I don't know the height, I can make a right triangle out of this, and since I broke up the 10, I can't use that. But I could instead say, hey, the sine of theta is h over 12. So my height is 12 times the sine of theta, whatever theta is. Okay, and we're going to look at the derivative specifically when the height is 60, or when theta is 60, but listen, when you're writing your function and taking the derivative, you don't want to use the 60 at that point. Okay? Now, I just showed you that's my height, so if I do 1/2 times the base times the height, that gives me the area. Okay? Now, you don't have to rederive that if you know the formula. The formula is the area equals 1/2 AB sine of C. That's the formula that's in the formula booklet. Okay? So notice, if you remember your general triangle ABC, the angles were across from the sides with the same letter. Okay, we just used capital and lowercase letters. So sides A and B would be the two sides we know. Angle C is just that whatever angle is between A and B. Alright, so in this case, theta is between the 10 and the 12. So we're going to use sine of theta. Alright, does that make sense? Okay. Alright, so here's our function. Our function A of theta is 5 times 6 is, or 5 times 12 would be 60 sine of theta. Do not plug the 60 degrees in yet though. Okay? Because we want the change, the rate of change in area. Okay? So that's A prime of theta. What's the derivative of 60 sine of theta? Yeah, it's 60 cosine theta. Okay? Now we can plug in the 60 degrees. So A prime of theta is 60 times the cosine of 60 degrees. What's cosine of 60? A half. So this is 30. And now we would want to go, we do want to think in terms of what our units would be. Okay? We are doing, and this is where looking at your derivative, not with the primes, but with the, in this case it would be the derivative of the area with respect to what?
Theta.
Theta. Okay? So that actually helps us find our units here. It's centimeters squared per degree. Okay? So our area is growing at a rate of 30 square centimeters per degree at that moment. Okay? So 1 degree makes a big difference here. Okay? From 59 to 60 or from 60 to 61, you're going to be around a 30 centimeter difference, 30 square centimeter difference in your area. Okay? Alright, does that make sense? Now, my goal is not to cover every possible application because we could spend the rest of the year on that. Alright? The point is, no matter what you're dealing with, the derivative is going to give you a rate of change for that context. You have to look at the context and figure out what exactly you're looking at, okay, and how you can use the derivative to find it. All right. So I gave you a few different problems. I didn't give you all the ones from this section because some of them were a little bit strange. or repetitive. So I gave you a few of these to try, and I want to give you the last 10 12 minutes here to go ahead and get started trying those, working on them together. So I'll let you work from here, okay?